This video is to do with antidifferentiation. So this is the next part of calculus. It's the reverse of differentiation, also known as integration. It gets the original function back. So we are given the gradient function and we then find the original function from that. To do that, we increase the power by 1 and divide by the new power. And again, it's got to be for each section of the function, so each term. And we always have to remember the plus c, and this is for indefinite integrals. So if we don't have enough information to find the c value, we have to remember to put plus c on the end. So the first example is antidifferentiate x squared. So we know that dy by dx is x squared. So what we do to get our original function back is we increase the power by 1, so we end up with x cubed, and then divide by the new power, x cubed over 3, and then we put the plus c on the end. So for the second one, where we've just got antidifferentiate 8, dy by dx equals 8, or it could be 8x to the power of 0. So when we get our original function back, we're just going to increase it to be 8x to the power of 1 over 1. However, we don't need to write that because power of 1 doesn't change anything and dividing by 1 also doesn't change anything. And then we need to put plus c on the end. Our third example is 5x to the power of 4 plus 4x cubed. So dy by dx is equal to 5x to the power of 4 plus 4x to the power of 3. So then when we increase our power by 1, we end up with 5x to the power of 5 divided by 5 plus 4x to the power of 4 divided by 4 plus c. And then we can simplify, so we just end up with x to the power of 5 plus x to the power of 4 plus c. Then our last one, for example 1, we would have dy by dx equals 2x, and then because it says 2x plus 3 on x squared, I'm actually going to write it as 3x to the power of negative 2 because it makes it easier. Just like when we do for differentiation, we move the power to the top, we're going to do that with this so it makes it easier. So we end up with 2x squared, y equals 2x squared over 2 plus 3x to the power of negative 1 over negative 1 plus c. So then when we simplify, we end up with x squared take 3 on x plus c. So the take sign comes from the fact that we were doing add, but we've now got 3 divided by negative 1, so it becomes negative. And that's the first example done. So we can also use the integration symbol, which is shown in example 2. It's like an elongated S. So we have find the integral of 12x cubed dx. So dx is just saying in terms of x. So to do that, we would do the same as what we did before. We would put the power up by 1 to be 4. So we've got 12x to the power of 4 over 4, add c, and then we just simplify that to become 3x to the power of 4 plus c. Again, it's an indefinite integral. We don't know anything about it, so we just put plus c on the end. This next example does give us enough information to find c. So what we have to do, it says if dy by dx equals 5 take away 9x squared, and when x equals 1, y equals 10, find y in terms of x. So the first thing is we need to antidifferentiate. So we increase power by 1, divide by the new power. So we end up with 5x take 9x cubed on 3 plus c, which would give us 5x take 3x cubed plus c. Now we can sub in x equals 1, y equals 10 to find c. So we end up with 10 equals 5 times 1 plus, take 3 brackets 1 cubed plus c. So we have 10 equals 5 take away 3, which is 2, plus c, so then c equals 8. So our final function would be y equals 5x take 3x cubed plus 8. That is the function that we started with for this particular example. So again, with anti-differentiation, we just need to remember, increase the power by 1 and divide by the new power. And if we have enough information, we can find c. Otherwise, we need to make sure we put plus c on the end.